Alright, here we go with our ecology review. Ecology. Study of how living things interact with one another. So I'm going to go down the items of things to focus on. I kind of did this yesterday at the study session. If you were not able to make it, that is okay. Those that came, I hope it helped you a whole bunch. So let's go down that list. One of the things it says difference between biotic and abiotic. You will have a question that will give you... Oh, I'm getting ahead of myself. A situation, and then they'll ask you about, what would be the biotic factor in this situation, or one of them, or what would be the abiotic factor in this situation. Can you pick them out? So the big thing is, do you know your vocabulary? Biotic, is that the living factors or the non-living?
Living.
They are living. So remember, the next unit, whenever we come back from spring break, is going to be about those living things. Like bacteria, protists, fungi, plants, animals. So can you pick out the living thing in that situation? But abiotic are those living things. No, those are non-living things. This is where students start getting confused. If you are non-living, what are some things you could be in an environment? You could be rocks. You could be soil. What else? The sunshine. What else could it be? Water. You could have air and all the things that make up air, like carbon dioxide, oxygen. What's something else? Weather. You could also put temperature in there, because temperature is part of weather. Precipitation. So those are things, remember, they help support living things, but they themselves are not living. Super duper important. Alright, everybody good with this one? Making sure you're separating these in your brain. Very important. If we look at terrestrial biomes, pretty much this is going to deal with climate. We're not going to ask you on the test, most likely they're not going to ask you about a specific biome. They want to know your, connecting of concepts. So if we think about the globe as a whole, that looks like an egg. Hold up. That looks less like an egg. So if we say that this is Earth, and we have the beautiful sunshine radiating down on the Earth, bless you, what part of the Earth is going to get the most solar energy? The equator. That nice invisible line that divides our Earth in half. It is going to get the most solar energy. Because of that, what type of climates will you see there? What kind of... Remember, climate is average weather conditions. So what kind of climate are you going to have or see if you're on the equator? You're going to be hot? Are you going to have a lot of rainfall?
No.
If you're on the equator. You can have a good bit of precipitation. So increase precip. There are very few places on the equator that don't have a lot of precipitation, like deserts. But remember, what's that one of those terrestrial biomes that has the most biodiversity. It has lots of plants and animals. It has a lot of precipitation all year round. It's really hot. Ah, the rainforest. It is on the equator. As you go away from the equator to the North Pole, who lives at the North Pole? Santa. And maybe you might go south. You go to the South Pole. What lives at the South Pole?
Penguins.
Penguins, like Happy Feet. So as you move away from the equator, are you going to increase in temperature or are you going to decrease in temperature as your climate? How's your climate going to be affected as you move away from the equator? It is going to. You're going to decrease in temp. Means you're going to get cooler. But remember, you can have different amounts of precipitation. But remember, like the Hadley model said, it picks up that rain and travels. So again, if you go south, you're going to decrease in your temperature. Bless you. But you're still going to have precipitation. So important to remember that. Because I know this is one of the first things we talked about. And as we move on, some things kind of start leaking out of our brain. So I just want to make sure it goes back in your brain. Alright, everybody got this one. Make sure. So remember, just like the Hadley model said, that wind is going to pick up that precipitation along the equator. That's why we get a lot of moisture coming from the Gulf of Mexico. It is closer to the equator. It picks up that moisture with the wind, takes it to us. Or sometimes you'll get some winds off the Pacific Ocean closer to the equator, picks it up, brings it on over. You hear about that nor'eastern wind or that nor'easter band of weather that's gone over the northeast. That's why they got all that snow. That's also why we got extremely cold temperatures for this time of year. All about that climate. Alright, may I get rid of this? Are we good? Alright, if we talk about aquatic biomes, I would make sure that I knew my layers of either lakes or oceans. So no matter what, if you are a body of water, draw me some type of soil on the bottom. Have us sunshine, because we need it. What is this part of any body of water that the sunlight actually penetrates and you can, have things growing there like algae, maybe some plants. This is your photic zone. Remember, photo. Think about the flash on a photo. What is that flash made up of? Light. So there is going to be a photic zone. What about that zone that the light does not penetrate anymore? What could I put in front of photic to make it not or non? Aphotic. This is right below the photic zone, but the light, it is far enough down that the light cannot penetrate it. And then, what's the very bottom of any type of body of water? It is the benthic zone. I would make sure that I knew the parts of my bodies of water. Please remember, things that live in the photic zone could be like water lilies. They could be some algae. They will be things that will go through photosynthesis, which is important. Things in the aphotic zone, it's going to be things more like fish. Things in the benthic zone, there's not going to be a lot that wants to live there. But I'll definitely know that. If we talk about something else with aquatic biomes, I'm getting ahead of myself. If you have, why did that not go away? Go away, little fella. If we think about our types of lakes or just bodies of water in general, if you are a colder body of water, do you have a lot of oxygen and nutrients? Think about that oleotrophic lake. It was nice and clear. Did it have enough, oxygen and nutrients for there to be life being there? No. So decreased O2, decreased nutrients. As opposed to warmer water. If you're warmer or warm water, you are the opposite of colder water. Think about that eutrophic lake, or, that midstream, those estuaries. Think about Gunnersville Lake. Is Gunnersville Lake clear, or is it kind of murky? It's kind of murky. What did we say that murkiness meant? Is that a bad thing or a good thing? It's a good thing. What does that murkiness represent? It has a lot of what in it? Nutrients. That also means it's got a good bit of oxygen in it. So they're slightly different. The colder you are, you won't have as much oxygen in you. You won't have as much nutrients. That's why there are very few things that want to live in oleotrophic lakes and the headwaters of rivers and streams. That's why in warmer places like eutrophic lakes, they have more oxygen. That means more life wants to be there because more nutrients can grow. Like those midstreams and those estuaries. Alright, are we good? May I get rid of this? If you need me to wait, I can. Another thing on your list of items to know is swamps and marshes. If you are in a swamp, do you have trees or tall grasses? Ooh, you have trees. Bless you. If you are in a marsh, do you have trees or reed grasses?
Reed grasses.
Tall reed grasses. But for both of these, why are they so important and we talk about them? They help do something to help with, holding water back. Shrek does live in a swamp. It's true, he does. But what's so important about swamps and marshes? They kind of help with hurricanes. They do something with all that water. They contain floodwaters from hurricanes. Remember, that is their purpose. That's why we like them. They also have a lot of biodiversity in them. And remember, marshes and swamps, they can have, they can both have alligators. They can both have, They can both have snakes. They can both have all kinds of wildlife. There is not just certain wildlife that lives in a certain one. But we like them because they can hold back and contain those floodwaters from hurricanes. That's why whenever hurricanes come into Florida or Louisiana, they worry about the swamp and they want to make sure, that things have not been washed away too bad. Because they know how important they are. They hold back those hurricane waters for them. Alright, everybody good with this one? May I get rid of it now? Alright, some survivorship curves. Remember, survivorship curves deals with parents taking care of their babies. We talked about songbirds, we talked about humans, we talked about frogs and fish. Remember, I have 3 types of survivorship curves. I got one that goes this way. Remember, this is birth. Things are born. Eventually everything dies. Death. I had one that goes this way. Alright, let's go a little bit more straight. Steady decline. So 1, 2, 3. So these are the ones that truly exist. For number 1, they have a lot, because remember, you read these left to right. If you read survivorship curve number 1, like we talked about before, does it look like they live a long time before they drop off and die? They do. What are some living things that are taken? If you live for a long time, did your parents take very good care of you? Yes. So this is pretty high parental care. So what are some living things that have high parental care? Humans. What are some others? Bears. Let's name one more.
Tigers.
Pardon? Yes, that is true. So tigers, elephants really do. Elephants take very good care of their young. Because, think about it. Humans and bears and elephants and tigers, do they have thousands upon thousands of offspring at a time, or do they have a few? They have a few. If you only have a few offspring, do you want to take good care of them? Yes, because you want your genetics to be able to be passed on to the next generation and for them to thrive and keep your lineage going. Number 2, if you read it left to right, what do you notice about it from birth to death? It is a steady decline. That means that this type of animal or, living thing is probably what for other living things? It's probably food. Anyone remember the animal we talked about for survivorship curve number 2? Birds. Small birds, baby birds, bird eggs. They are notorious for being food sources for other animals, other living things. Also, mama bird eventually kicks baby birds out of the nest. Some of them, they learn to fly. They're good. Some fall to their death. So they have a steady decline all the way through their lifespan. It is possible. And then the third one, if you read it left to right, what do you notice about it? Ooh, we're just going straight down. So, is there, a very long life expectancy in curve number 3? No. These are living things that have probably, do they have a lot of offspring at one time? Yes, they have thousands, hundreds and thousands. Anybody remember what animals we talked about that have thousands? Frogs.
Fish.
fish, spiders. Turtles actually have very good parental care. They do. They do.
Sea turtles.
They do.
They lay them and just go into the water.
They bury them. They keep them safe from other predators because they gotta lay them on land somewhere. We will find out next unit. Next unit. They have actually very good parental care. They're one of the very few aquatic organisms that have very good parental care. But if you are frogs and fish and spiders, you lay thousands upon thousands of eggs. Can you take care of all thousands of those eggs? No. Alright, I shall clear this. Alright, next thing, age pyramids. You will be given an age pyramid and you will be asked something about that age pyramid. You will have to interpret the age pyramid like we did with the U.S. Census. So let's say, remember, it is usually divided between men and women. And then they always have age groups. Usually the one up top is 80 plus. The one at the bottom is 0 to 4. Then usually there's the pre-puberty, which is 5 to, I think they say, it depends on what one. Some say 5 to 12, some say 5 to 13. And then some say 13 to 21 or 20. Then usually you have 21 to usually about 35 sometimes. Sometimes you'll have 36 to 50, 51 to 70, 80 plus. You'll have different ones. You'll have those age groups. And then they will have different bars representing how many men versus women versus age groups of what you can have. Can I please get rid of my age groups? Anybody still getting their age groups? Anybody? Alright, keep getting your age groups. That is okay. Please remember all of the ecology videos are still on Google Classroom. They're still on YouTube. If you need to go back and look at something because you can't remember how I explained it, they are on there. They're a great study tool. I have lots of videos on my ecology playlist in case you've forgotten something or you have a blank moment. Go check them out. Please remember, hey, you can't email me. Just don't email me tonight at 10 o'clock and say, could you explain that to me again? I promise you I will not be awake. I will be I will be asleep, for reals. So if you have a question, please email early so I can answer it. Not at 6 o'clock the next morning or 5 whenever I wake up. Alright, may I get rid of my age groups? Alright, if we look at this, let's say that, let's say for 0 to 4 we have this going on. For 5 to 13 we kind of have this going on. For 80 plus up here, we have this going on. And then usually from middle age, about 20s, we have about, this going on. And then older than that, usually about 30s, 50s. If you notice from the '80s plus, why do you think, you will be asked to interpret this, why do you think there are more women than men? What could be a cause of that? War. Well, men typically do not live as long as women because they tend to be risk factors involved with them, like, they don't take very good care of their health most of the time, they have risky behavior, they like to do, not so smart decision things. But the most logical reason is what happened during their lifetime, war. For, let's say that this is a country like China, and you have the age group of through in here, 30 to 50, what do you notice about the number of men versus women? There's a lot more men than women. What was that nice law we talked about that was put forth in China? One child law. What children, what gender did they mainly choose to keep? Men. Why would they want that? Carry on the family name. Most women were put up for adoption. So, what do you think could be an effect of them having an increased number of men as opposed to women? What could that have an effect on in their country? Children being born. For a good while, I'm not sure if they're still having this problem because they've lifted that ban, that law. They've reversed it. For a ratio to men to women, there are 4 men for every 1 woman. There's a lot of competition. For reals. And in the human species, pretty much women choose. Yeah, that's how we roll, because we're like, you cray-cray, you don't have no job, you live in your mama's basement, scrub, TLC, I don't want no scrub. For reals. Alright, so age pyramids, you're going to be given one and they're going to ask you something about what's going on. And as we can see, if you are like a country like China, from the age groups of, this is 0 to 10, you're not having a lot of children. It's not booming as much as it probably should. And this is an after effect. Remember, age pyramids, what is that survey that they send out every 10 years? Census. They use that census, the information, how many people are in your house, what are the age groups, so they can build age pyramids and see, what are the effects of certain things going on. Boom and bust. Just remember, wake up, wake up. It's okay. Alright, so, boom. Do you think this is a population increasing or decreasing? Increasing. Bust is what? Decreasing. Remember, this is just a predator-prey relationship. This is that snowshoe hare and that lynx. As, let's say that the bunny rabbits are purple. Let's choose, we'll go with orange. Orange is that lynx. If the bunny rabbits start a-growing and a-growing and a-growing, they are booming. What is also going to happen to the population of lynx? Is it going to increase or decrease as well? It be increasing. What's going to happen to all them bunny rabbits if there be all them lynx up in there? What's going to happen to them? They're going to die. Why? Oh, they be getting 8 on the plate. So they are going to start decreasing because they all getting 8 on the plate. What's going to happen to them poor lynxes? Why are they going to die? Because they starving. So they can nothing to eat. After a while, because, you know, there's no lynx to eat them, what's going to happen to all them bunny rabbits?
They're not going to die as much.
They're not going to die as much, and they're going to be able to what? They're going to be able to live. They're going to reproduce. Boom it again. Ooh, well, what's going to happen to all them lynx? What are they going to say to themselves? Be like, food, bunny buffet. And this is going to keep going forever and ever 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 and ever. Alright, in this situation, the bunny rabbit is what? Is it the predator or the prey? The prey. And then what about that lynx? Predator. Predator-prey relationship. Super important. Super important. Please remember 10% rule. If you need to go from one trophic level to another to find out what amount of energy they gain from eating the previous organism, what number did you divide by? 10. Make sure that you know this, relative abundance. And then species richness. That's important. Remember, this is in a community. Communities are those, the same species or different species? Different. Relative abundance. Abundance. Is that the, number of each different species? Or is it just the different number of species? Is it the number of individuals within each species? Or is it just the overall different number of species? What is it? That is unacceptable. So which one is it? Is it the number within each species, or is it the different number of species? Number within each species. Remember we talked about Gunnersville State Park. Let's say you got 100 deer. Let's say you got 3,000 squirrels. And let's say that you have, they're starting to increase. You have 400 eagles. They are repopulating finally. Species richness, though, is not the number within each species, but the what? Number of different species. So let's say that you had 520 species there. You have 520 species there. That could be made up of deer, squirrels, eagles, lynx, bobcats, what have you. Relative abundance is the number within that 520. Of that 520, how many are eagles? How many are deer? How many are them bobcats? Super important. Super important. Please make sure that whenever you look at acid, or I was going to say acidic, acid precipitation, we know what it is. It's precipitation that has a pH of 5.6 or lower, because we learned about that whenever we talked about properties of water. Make sure that you know its effects. That's the important part. What does it do to things, living things? Make sure you know that Hardy-Weinberg. Make sure you know what P squared, 2PQ, Q squared stands for. Make sure you know what P and Q stand for. Make sure you know those things. It is super important. Alright, that is it for our review. If you have a question, please email me. But make sure you email me from your personal email account so I can send you a response. If you send it to me over Google Classroom, it will tell me inbox does not exist. So, please send it to me that way.